Today we're going to be looking at how to solve a system of linear equations using the inverse of the coefficient matrix. So recall, when you have a system of linear equations, we can then rewrite it in matrix form. Right? So the system above can be rewritten in the following form: AX equals to B, where A is the coefficient matrix, X is the variable matrix, and B is the constants from the right hand side. So we have that A is then equal to, so looking at the coefficients, we have three variables, x1, x2, and x3. So I know there's going to be three columns. So working with x1, the coefficients of x1 is 1, 4, 1. So I'm writing that down in the first column. The coefficients of x2 is 0, minus 2, and positive 2. The coefficients of x3 is minus 2, positive 1, and minus 10. So that is the coefficient matrix for that original system. The variable matrix is just going to be a 3 by 1 matrix consisting of the variables x1, x2, and x3. And the constants matrix is going to consist of the right hand side constants, positive 1, positive 2, negative 1. Now, once we have our system written in matrix form, which is what we have as follows, it is important to note that the solution to this system, meaning that X, is equals to A inverse being matrix multiplied to B. So that means in order to solve this system, we need to find A inverse, assuming, of course, A is invertible. Well, in this example, A is invertible, so we will be able to find the inverse of A. Right, so let's get into our method of finding the inverse of A. So remember, the first thing that you have to do is create an augmented matrix, where you write down matrix A, followed by the identity, which is the same size of matrix A. Matrix A is size 3 by 3, so we need the identity of size 3 by 3, so we require I3. So let's write down this augmented matrix. I'm going to copy down matrix A, 1, 0, minus 2, positive 4, minus 2, 1. In the last row, 1, 2, negative 10. I write down my vertical line, and I now write down the identity matrix. Oops. This is meant to be a 0, and that's a 1. Right, so the identity consists of 1s on the main diagonal and 0s elsewhere. I'm just going to label this row 1, row 2, and row 3. Now, once you've created this augmented matrix, remember the procedure. We now need to apply row operations such that we can convert matrix A on the left-hand side into something that is row reduced. Ideally, what we want to do is we will apply row operations to this augmented matrix such that we end up with an augmented matrix that has the following form. We would like to ideally convert A into I3, followed by whatever happens on the right hand side. If we can arrive at this using row operations, then that matrix B on the right hand side of the vertical line will then be A inverse. So let's now apply row operations to write down A in reduced form, keeping in mind that whatever you do on the left, you have to do on the right. Okay, so let's row reduce. So remember, when we are row reducing, I had advised you to work with your columns from left to right. Right, and the idea was that in column 1, you will then work with entry 1 in column 1 and convert it to 1. Observe that we already have 1 in entry 1 in column 1, so that means that row will remain unchanged. So I'm just going to copy that down. Right, and then once you have a 1 in entry 1, you then need to create, once you have a 1 in entry 1 of column 1, you then need to create zeros below it. Right, so that's what we are now aiming to do. Right, so how do we create the zeros below it? We now use our row operations. Remember, the idea is you take each row and you add a multiple of the row containing the pivot, and here's our pivot. It's in row 1. So since this is 4 and I need to convert it to 0, that means I need a multiple of minus 4 times the row containing the pivot. So that means row 2 must then be will then obtain a 0 by taking row 2 and adding it to minus 4 times row 1. Right, so that is how I will obtain a 0 here. So let's apply this operation to get the rest of the entries. Right, so it's 4 minus 4 times 1 gives me the desired 0. Minus 2 being added to minus 4 times 0 gives me a value of minus 2. 1 being added to minus 4 times minus 2 is actually 1 being added to 8, and that gives me 9. 0 being added to minus 4 times 1 is going to give me a value of minus 4. 1 being added to minus 4 times 0 gives me a value of 1. And 0 being added to minus 4 times 0 gives me a value of 0. Now remember, we're going to take a 1 and we would like to convert it into a 0. Again, using our row operations, we're working in row 3. I would then have to add minus 1 times a row containing the pivot. So it's minus row 1. So we're taking row 3 minus row 1. 1 minus 1 gives me the desired 0. 2 minus 0 gives me 2. Minus 10 minus 2 times minus 1 is actually just minus 10 plus 2, which is minus 8. 0 being added to minus 1 times 1 is minus 1. 0 being added to minus 1 times 0 is 0. And 1 being added to minus 1 times 0 is 1. So we have in fact created a unit column in column 1. So I'm now done in column 1 and I now need to move to column 2. Right, so let's continue with our procedure. Right, so continuing with this procedure, since I'm working in column 2, recall that in column 2 you now need to work with the second entry in column 2. So I would like to convert that minus 2 into a 1 and ensure that I have zeros above and below it. For now, let's just work with converting that minus 2 into positive 1. How would you do that? We can then multiply by a non-zero constant. So I'm going to multiply row 2 by negative half. If I do that, minus 2 times negative half gives me positive 1. So just completing the rest of the row, then observe 0 times minus half is 0. Minus 9 times minus half is minus 9 over 2. Minus 4 times minus half gives me a value of positive 2. 1 times minus half is minus half. And 0 times minus half is 0. I'm just going to copy down row 1 and row 3 as it is. So I will leave it unchanged for now. Right, in the next stage, we are now going to work to create the zeros above and below that pivot entry. Observe, we already have the 0 above it, so I have to work to convert the 2 into a 0 in the next stage. Alright, so since that is 0, which is what is desired, I'm simply going to copy that entire row as it is. It can be unchanged. That is already what's required, so again, I'm going to copy it as it is. And now we're working to convert that 2 into a 0. And remember, we have to make use of the row containing the pivot when we do this transformation. So that 2, which needs to become a 0, is in row 3. So what multiple of the row containing the pivot needs to be added to it? I need minus 2 times row 2 to be added to that. Right, and let's do the calculation. I need 0 being added to minus 2 times 0, which is 0. 2 being added to minus 2 times 1 gives me the desired 0. Minus 8 being added to minus 2 times minus 9 over 2. If you do that, you would get a value of 1. Minus 1 being added to minus 2 times 2 gives you a value of minus 5. 0 being added to minus 2 times negative half is 1. And 1 being added to minus 2 times 0 gives you a value of 1. So continuing with our procedure, notice now that column 2 is a unit column. So that means this is done and I now can move to column 3. Remember, what do we have to do in this column? I want to convert. In column 3, I need to work with the third entry in column 3. That needs to be 1 and everything else above it needs to be 0. But observe that this is already a 1. So that means I do not need to do any conversion, so I'm just going to copy that row as we see it. And let me box it because this is now my pivot entry. Remember, what do I want? I want zeros above it. So that is what I'm working towards at this stage. Right, so let's work with converting row 1. There is an entry of -2 and I require a 0. Right, so in row 1, what multiple of the row containing the pivot should be added to it to give me 0? Since that's -2, I need +2 times the row containing the pivot. Right, so let's complete that operation. -2 being added to 2 times 1 is 0. 0 being added to 2 times 0 is 0. 1 being added to 2 times 0 is 1. Right, repeating on the right hand side. 1 being added to 2 times -5 is -9. 0 being added to 2 times 1 is 2. 0 being added to 2 times 1 is 2. Right, so I've got the desired 0. Next, I need to convert -9 over 2 into 0. So that's in row 2. So what multiple of the row containing the pivot should be added to -9 over 2? It's clear that I need 9 over 2 to be added to it. So 9 over 2 times that, times 1 should be added. Right, so that's in row 3. So let's repeat the procedure. -9 over 2 being added to 9 over 2 times 1 gives me 0. Continuing with the rest of the entries, 0 being added to 9 over 2 times 0 gives me 0. 1 being added to 9 over 2 times 0 gives me 1. 2 being added to 9 over 2 times -5. This, if you just check very quickly, is -41 over 2. -half being added to 9 over 2 gives me a value of 4. 0 being added to 9 over 2 gives me a value of 9 over 2. And observe that on the left hand side we now have I3. This is the identity matrix. So we stop because we are in row reduced form, and this would have been the matrix B, but now whatever's on the right hand side, since this is the identity, is now A inverse. So we have that A inverse is this 3 by 3 matrix on the right hand side. So now let's go back to our question. Remember that we want to solve the system. In order to solve the system, we need to take A inverse and multiply it to B. So let's do that. So X is equal to A inverse times B. A inverse has entries -2, 2, and 2 in the first row, -41 over 2, +4 and 9 over 2 in the second row, -5, 1, and 1 in the third row. That is a 3 by 3 matrix, and it's being multiplied to matrix B, which is a 3 by 1 matrix which has entries 1, 2, and -1. Right, so the resultant size, the size of X, is 3 by 1 as you would expect, and we will be obtaining the solutions to X1, X2, and X3. That is what we will be obtaining. So that is what we want to obtain. Right, so what is X1 equal to? So remember, X1 is then going to be equal to row 1 being multiplied to column 1. So the entries in row 1 being multiplied to corresponding entries in column 1. So that is -9 times 1 plus 2 times 2 plus 2 times -1. And your answer there is -7. Repeating the procedure, taking the entries in in row 2 being multiplied to corresponding entries in column 2 and adding them together, you get -17. And repeating for the third row, taking the entries in the third row, multiplying to the corresponding entries in the first column, you will then get a solution of -4. So X1 equals -7, X2 equals -17, and X3 equals to -4.